Okay, so essentially, the premise of solving special right triangle problems is that you are applying two different ratios, the 30-60-90 ratio and the 45-45-90 ratio, into different numbers which represent the variable. So, for example, when we had 14 root 2, that represented 2x, so then to find regular x, we just divided by 2. So in order to find the value of y on this 45-45-90 triangle, we need to fill out this side on the 30-60-90 triangle because that connects the two triangles together. So now that we know what x is, right, 7 root 2, all we have to do is plug it into the ratio so that we can find what this side is, and then from finding this side, we can find out what this side is, which is the other variable. So all you have to do to find this side is plug in x, which is 7 root 2 times root 3. And then when you're multiplying two radicals, you just multiply what's inside. That creates 7 root 6, and this can't be simplified. So we found out what the value is for this connecting side, 7 root 6, and now we have successfully connected this triangle to this triangle. So again, in order to find the value of this 45-45-90 triangle, the hypotenuse specifically, all we have to do is again plug in the ratio. So when you look here at the 45-45-90 ratio, these two sides are the same, so we automatically know that this is also 7 root 6. And then to find the hypotenuse, all we have to do is multiply what we have for either of these sides by root 2. So we're going to go 7 root 6 by root 2, which equals 7 root 12. But you're not done because root 12 can be simplified. So we're going to break this down into root 2, root 3, and root 2. 2 times 3 is 6, and then 6 times 2 is 12. And if you look at these numbers, they can't be broken down any simpler than that, right? So we know with the radical rule that the square root of 2 times the square root of 2 is just regular 2. So that means that what we have here is actually 7 times the base of 2, root 3. And then 7 times 2 equals 14, meaning that the hypotenuse, y, equals 14 root 3.